Mark your calendar for January 19th, 2038, at precisely 3:14 and 7 seconds a.m. Universal Time. A massive portion of our digital infrastructure stops. Global GPS networks will drop offline, millions of smart devices will freeze, and banking servers worldwide will abruptly reject every incoming transaction. Inside these machines, internal clocks will instantly snap backward to a very specific date in the past, December 13th, 1901. This collapse occurs without a single line of malicious code or a sudden, unpredictable software bug. Known as the 2038 problem, this event is a built-in mathematical certainty. Early engineers effectively hard-coded an expiration date into the digital world, leaving our foundational infrastructure to run on a clock that eventually runs out of room. To understand why this date is fatal, we have to look at how machines process time. Computers do not read calendars or wear watches. They track time by counting single passing seconds. This timeline illustrates how they do it. It starts at day 0 for modern systems, January 1st, 1970, an anchor point engineers call the Unix epoch. Every second since that day has been steadily tallied up into one massive, continuously growing number. Back in the 1970s, computing memory came at an extreme premium. Storing even tiny amounts of data required huge physical space and heavy financial costs, forcing programmers to conserve every byte they could. Their solution for timekeeping was to use a 32-bit integer. You can think of this as a rigid memory box of a fixed size, built specifically to store that running tally of seconds. By cutting corners to save physical space half a century ago, those engineers imposed a strict mathematical ceiling on how far into the future our systems can count. This 32-bit memory box holds a strict maximum of 2.14 billion seconds. As time ticks, it fills. On January 19, 2038, hitting capacity, adding just one more second, breaks the logic. The math overflows, instantly snapping backward to its maximum negative value. The computer suddenly calculates the current time as being more than 2 billion seconds before day 0. It assumes the year is 1901. When the calendar forcefully reverses by over a century, modern security certificates immediately register as long expired. Automated banking algorithms reject clearance requests, and aviation navigation systems lose the precise temporal anchors they need to map flights. An invisible limitation in binary code creates a direct, cascading physical failure across the global networks we rely on daily. You might immediately think of the Y2K panic at the turn of the millennium, but drawing that comparison offers a false sense of security. The year 2000 glitch was a relatively shallow programming oversight. Companies avoided disaster by rolling out massive software patches and rewriting surface-level code over the internet. The 2038 problem sits much deeper. The 32-bit limit is physically hard-coded into the architecture of embedded hardware chips spread across the globe. We are dealing with unpatchable microprocessors, baked into factory routing machines, municipal smart grids, and aging medical equipment locked away in hospital basements. You cannot download a patch to fix a physical hardware constraint. An over-the-air update is impossible. Right now, engineers are running a quiet, desperate race. They are physically tracking down old 32-bit architectures and manually swapping them for modern 64-bit systems. Moving to a larger 64-bit container gives us enough memory to safely and accurately count seconds for another 292 billion years. But there will be permanent casualties. Millions of legacy devices operate as isolated infrastructure, or they orbit high above the Earth as satellites. These systems will simply never be reached or upgraded in time. When the digital clock finally runs out of mathematical room in the year 2038, those isolated systems will quietly and instantly die. We build our digital society with visions of a limitless future, yet we remain tightly tethered to the physical memory constraints of the 1970s. We are trapped in a perpetual race against our own foundational code.